I welcome you all for another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the three questions. Question number 9, 10, 11 from the section Sets, Relations and Functions, that is Unit 1, that have appeared in the JEE Main January 2024-25 session. These questions are related to sets and equivalence relations. Question number 9. This question has appeared in the JEE Main 23rd January 2025 in the morning shift. It is related to equivalence relations. The given question is, let R is equal to the set consisting of three ordered pairs 1, 2, 2, 3, 3, 3 be a relation defined on the set consisting of 4 elements 1, 2, 3, 4. Then the minimum number of elements, that is the minimum number of ordered pairs needed to be added in R so that R becomes an equivalence relation is, we are given 4 options. Right, it is a very simple question. Let's now discuss the solution of the problem in detail. We are given S. Let S be the set consisting of the elements 1, 2, 3, 4. We are given R is a relation on S, where R is given as ordered pairs 1, 2, 2, 3, 3, 3. It's a relation on S. Agreed. Now, then the minimum number of elements needed to be adjoined to R so that R becomes reflexive. First of all, we take this R. Is this R an equivalence relation? No. So, to make this R an equivalence relation, we will adjoin those elements, those ordered pairs to R so that this R, when added those elements, becomes reflexive. So in R we only have 3, 3. To make it reflexive, we need A, A belongs to R. For all A belongs to S. So we have to adjoin 1, 1, 2, 2, 4, 4 and 3, 3 is anyway there in R. So we have to adjoin 3 ordered pairs so that R becomes reflexive. Then the resulting R, we call it as R prime. Let R prime be, after adjoinment, 1, 1, 2, 2, 4, 2. These are the elements which we have adjoined. And 1, 2, 2, 3, 2, 3, 3 is already there. Now the question is it an equivalence relation? No. Why? Because symmetric property is not satisfied. And you need not check for this ordered pair, say, A, the symmetric property. It is already there. So 1, 2 belongs to R prime, but 2, 1 is not there in R prime because the symmetric nature is not there. 2, 3 is there in R prime, but 3, 2 is not there. So to make it symmetric, we will adjoin this 2, 1, the minimum number of elements needed to be adjoined to R prime so that R prime becomes symmetric, or 2, 1, 3, 2. So 2 ordered pairs we will be adding. Now you adjoin, then the resulting relation is R double prime is equal to 1 1 2 2 4 4 1 2 2 3 3 3 3, and these are the two elements which we have added 2 1 3 2. Now look at this R double prime. Is it transitive? Is it transitive? Now see, 1 2 belongs to R double prime, 2 3 belongs to R double prime, and to be transitive 1 2 2 3 when composed you will get 1 comma 3. Is 1 comma 3 in this? No. So we have to adjoin that element. But you want an equivalence relation, it should also be symmetric. When you adjoin 1 3, 3 1 also you have to adjoin. And look for the transitivity again. 1 2 2 3 1 3, and the symmetric is 3 1, and any other. See, so the minimum number of elements needed to be adjoined to R double prime so that R double prime becomes transitive and symmetric, both 1 comma 3 3 comma 1. 2 ordered pairs you have to add. So after the adjoinment, this becomes R star. R star is set of all those. Now the adjoined ones is 1 3 3 1. So now it is an equivalence relation. You can check reflexivity and symmetric. Symmetry is also there, and transitivity is also there in this. Therefore, thus it is an equivalence relation. So it may be checked that R star is an equivalence relation on S. Right. How many elements we have adjoined? Ordered pairs we have adjoined 3 plus 2 plus 2, 7. So the minimum number of elements, that is the ordered pairs, needed to be adjoined to R so that R becomes an equivalence relation is 7. 7 elements, 7 ordered pairs are the minimum number of ordered pairs to be adjoined to R so that R becomes an equivalence relation. So let's look at the options. Our answer 7 appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of this problem. It is definitely an easy problem. Move to the next question, question number 10. This question has appeared on 22nd January 2025 in the morning shift exam, and it is related to sets. Let A be the set consisting of 1, 2, 3 up to 10, and B is the set consisting of m by n, where m and n belongs to A, m less than n, and the GCD of m comma n is 1. Right? So then the order of B, number of elements present in B is equal to, we are given 4 options. Agreed. Now let's now discuss the solution of the problem in detail. Right. Now given A, the set consisting of 1, 2, 3 up to 10, and we want to find the number of elements present in B, where B is the set of all m by n, where m and n belongs to A, m less than n, and the GCD of m comma n, that means is equal to 1. That means m and n are relatively prime. Agreed. For this, we have brought you a table here. Now, we first of all consider n. N, what is n in B? N is sitting in the denominator. So if you take n is equal to 1, what are all those elements of A? Less than 1, no elements. Therefore, n is equal to 1 is not considered. So now n is equal to 2. So what are all those elements less than 2? in A is only 1. And out of these m's, now how many of them are relatively prime to n? So GCD of 2 and 1 is 1. So what are the elements? Less than n, which are relatively prime to n. It's only 1. This one. Now, in B, the quotients are there, m by n. So, m is 1 by 2. So, how many number of m by n are there? 1 only. So, it's practically the number what you get here, you will be getting here m by n. Now, n is equal to 3. So, what are those elements in A? Less than 3, 1, 2. Now, what are those elements which are relatively prime to 3, which are less than n, less than 3? 3, 1 is 1, 3, 2 is 1. So, 1 qualifies, 2 qualifies, 1, 2. So, now m by n, m is 1 by 3, m is 2 by 3. How many? 2. So, the number of m by n is 2. 4. All the elements in A less than 4, 1, 2, 3. Now, what are the elements which are relatively prime? 4, 1, GCD of 4 and 1 is 1. 4 and 2 is not 1, therefore 2 is not considered here. And GCD of 4 and 3 is 1, therefore 3 qualifies. How many elements? 2 elements. What are the quotients? The quotients are 1 by 4, 3 by 4. How many? 2. So now go to 5. Elements of A less than 5. 1, 2, 3, 4. And 5 being a prime number, 5 is relatively prime to each one of these elements. So 5, 1 is 1, 5, 2 is 1, 5, 3 is 1, 5, 4 is 1. So all of them will qualify. So now how many m's? 1, 2, 3, 4. 4 elements, therefore 4. So the quotients are 1 by 5, 2 by 5, 3 by 5, 4 by 5. They are 4 in number. 6. Next n is 6. The elements of A which are less than 6 are 1, 2, 3, 4, 5. 6, 1 is 1, so 1 is qualified. 6, 2 is not qualified. 6, 3 is not qualified. 6, 4 is 2, not qualified. 6, 5 is qualified. GCD is 1. So 1, 5 only. So the number of m by n is 2. 7. So elements of A which are less than 7 are 1, 2, 3, 4, 5, 6. And 7 being a prime, every element is relatively prime to 7. So the GCD of m, n is 1. Who are the m's? All these 1, 2, 3, 4, 5, 6. And the m by n's number is 6. Next 8. And elements of A which are less than 8 is 1, 2, 3, 4, 5, 6, 7. And what are those elements which are relatively prime with 8 out of these is 1, 3, 5, 7. They are 4 in number. The number of m by n will be 4. N is 9. We get 1, 2, 3, 4, 6, 7, 8. And in this 9, 3 is 3. They are not relatively prime. 9, 6. The GCD is 3. They are not relatively prime. Therefore, the remaining 1, 2, 4, 5, 7, 8. Right. How many? These are 6. So, lastly, we go to n is equal to 10. And what are those elements which are of A, which are less than 10? 1, 2, 3 up to 9. And what are the elements which are relatively prime with 10? 10, 2 is not. 10, 4 is not. 10, 5 is not. 10, 6 is not. 10, 8 is not. So, the remaining are 1, 3, 7, 9. How many? 4. So, thus, The number of m by n are given by the sum of these numbers. So the total, so we get the total number is when you add all these, you get 31. So the number of elements in B is given by 31. Let's look at our options. Our answer 31 appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of this problem. Move to the last question, question number 11. Right. This question has appeared in the JEE Main exam held on 22nd January 2025 in the morning shift. It is related to, again, on equivalence relations. The given question is the number of non-empty equivalence relations on the set consisting of 1, 2, 3 is options. 4 options are given here, and these are the 4 options. Right. So let's now discuss the solution of the problem in detail. Let A be the set consisting of 1, 2, 3. Right. And to find the number of equivalence relations on A. And since every equivalence relation R on A is reflexive, reflexive means A comma, the ordered pair A comma A belongs to R for all A belongs to A. So in R, there should be 1 comma 1, 2 comma 2, 3 comma 3. Let R1 be 1 comma 1, 2 comma 2, 3 comma 3. It is reflexive. Is it symmetric? Yes. 1 1, 1 1, 2 2, 2 2, 3 3, 3 3. Is it transitive? Yes. Yes. So here many of our students ask the question, sir, how to test transitivity here? Read the definition of transitivity. What the definition of the transitivity says? Whenever A comma B and B comma C belongs to R, then A comma C belongs to R. Read carefully. Whenever. So is there a comma B and B comma C in R1? No. When there are no such elements, there is no question of the transitivity coming into the picture. Therefore, transitivity is not failed. Therefore, transitivity is satisfied. Right. It has a reflexive, symmetric and transitive. Thus, R1 is an equivalence relation. So, thus we got a first equivalence relation in that. So, as we did in the earlier question, now to this set, to this R1, we adjoin some elements so that it becomes reflexive. It becomes an equivalence relation. Now, let R2 be, we adjoin 2 elements. 1, 2. Because we have adjoined 1, 2, we want symmetric. 2, 1 also will adjoin. Now test for transitivity. Is again I tell you, whenever A comma B and B comma C belongs to R, then A comma C belongs to R. So transitivity is also satisfied. So it is an equivalence relation on A. In a similar fashion, go to R1 and adjoin in this similar form 1 2 after 1 2 1 3. If you add 1 3, add also 3 comma 1. So let R3 is all those reflexive elements 1 3 3 1. It's also reflexive, symmetric and transitive. In a similar fashion, next one 2 comma 3 and 3 comma 2 is also to be added. So R3 is an equivalence relation. R4, in the case of R4, 2, 3, 3, 2. And R4 is also an equivalence relation. That's all. So adjoining one element and its symmetric element results in equivalence relations like this. So basically you have that reflexive elements are there. To them we are adding. Now suppose you add 1, 2 and you want to 1, 1, 3 also. 1, 3 also. Then it becomes the whole set A cross A. A cross A. So let R5 is equal to A cross A. That is 9 elements you have to write. So these are the 9 elements of the ordered pairs. A cross A means the Cartesian product of A with itself. A has 3 elements. A cross A will have 9 elements. These are the 9 elements we have written. And it is the whole A cross A, and the whole A cross A is always reflexive, symmetric and transitive. Therefore, it is an equivalence relation. R5 is an equivalence relation on A. Right. Thus, we have obtained 5 equivalence relations on A. Therefore, the number of equivalence relations on A is 5. So, the answer to this question is option 1. It's not option 5. Option 5 is not anywhere there. The answer is 5. Option is 5. The answer is option 1. And in option 1, we have 5. The 5 we have written by mistake. Right. That is the detailed discussion of the solution of this problem. Now, it is worth mentioning here, is there, this is not for IIT JEE Main students and those of you who are going for the advanced, they can think of, how many equivalence relations are there on a given set A consisting of n elements. For 3, 5. For 4, how many? For 5, that means for 5 means for the number of elements are 5, how many? And there are methods of doing it. And please prepare such a kind of notes on order 3, order 4, order 5. There is a method of doing it also. This is a very elementary method what I have shown you, and that is worth making a notes on the number of equivalence relations on the set consisting of 3, 4, 5. That will be interesting and that will be useful to you. I am sure that you have understood the solutions of these 3 questions. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will definitely meet you again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.